Hello students, welcome to Legacy IAS Academy. Today we are going to discuss about that what are the major upcoming space missions that ISRO, that is Indian Space Research Organization, is planning for the year 2022. What are the aims, objectives and the progress of these said missions? So the context in which we are discussing this particular issue is because recently ISRO has announced on the May 13th that it has successfully tested the HS-200 SRB, that is solid rocket booster, which is going to be a very integral part of its oncoming space mission that is called as Gaganyaan. The successful completion of this test marks a very major milestone for the first human space flight mission which India is aiming for. ISRO's upcoming mission this year focus on manned space travel Gaganyaan. The second important mission that is going to be launched is Aditya L1 for studying the sun, and the third important mission is going to be the third Chandrayaan or Chandrayaan III, where the ISRO will try to soft land its rover as compared to the last time. Apart from these three missions, there are several satellite launches also are planned, which are both domestic and foreign in nature, both governmental as well as commercial in nature. So in this particular video, we are going to discuss about all these three major flagship missions, and apart from that, which are the satellites that the ISRO is planning to launch. So let us start our topic of discussion with the Gaganyaan, which is most talked space mission in the history of India. So what mainly Gaganyaan is trying to achieve? So Gaganyaan is going to be the first crewed mission of India in space. Before also India has sent many times satellites and all these things, but for the first time India is trying to send a human on its own capabilities in its own indigenous spaceship. The mission is scheduled to undertake its unmanned flight somewhere in the second half of 2022. However, the Gaganyaan is not only a crewed mission, there are two missions also. So those two missions will be unmanned and one mission will be manned. That means in two missions there will be no human, in one mission there will be a human. The objective of Gaganyaan is to prove prove the ISRO's capabilities, that it is capable of a human space flight in the low Earth orbit and then is able to return the human back to the Earth. The most important, if you look at the expenditure behind this mission, it is expected that it will take around 9,023 crore. If we want to remind you that few years back, India was able to launch another mission on Mars that is called as Chandrayaan mission, and whose cost was much more lower, and many times it is being said also that the cost of the India's Chandrayaan mission was even lower than the cost of the movie that was made in Hollywood called as Gravity. The manned mission is expected to take up to 7 days, and after that it will come back to Earth. Now, what is the main aim and objective of this Gaganyaan mission? So, first of all, if the mission is successful, it will lay the foundation for a sustained Indian human space exploration program. Due to this, India will join the League of Nations and will become the 4th country in the world to have capabilities or also to have sent human to the space after countries like US, Russia and China. And if the mission becomes successful, it will also lay the groundwork for India to develop its own space station, similarly on the line of we can say International Space Station, which is a collaborative effort of several countries, mainly of NASA, a Mir space station that used to be a space station of Russia, and one of the space station that also has been launched by Tiangong space station that also has been launched by the China. So this will help India also in the scientific and technological development, because then India will be able to conduct research in various fields, especially the fundamental, applied and engineering sciences. So how far the progress has been achieved about the Gaganyaan mission? So as per the report released by the ISRO, a new training center where astronauts who will be sent to the through the Gaganyaan mission is already being constructed at the ISTRAC, that is ISRO Telemetry Tracking Command Network in the Bengaluru. At the same time, ISRO has also been successfully able to develop all the technologies that will be required for the success of this mission, and all these technologies have been developed at the indigenous level. And third, the engine qualification requirement of the mission have also been successfully completed. So let us try to understand about all these in little more detail. So first of all, the Gaganyaan module will comprise of total 6 different parts. The first important component is human rated launch vehicle. That means there will be a launch vehicle in which it will be possible to send a human. This human rated launch vehicle will be launched on ISRO's workhorse, that is GSLV Mk3. If you look at the design of this space module, On the upper part of this launch vehicle will have a crew module as well as a crew escape system. Apart from that, this module will also have a life support system, specifically where the requirement of oxygen and other vital requirement will be met for the astronaut. Not only that, the space module will also be fitted with a human rated cryogenic engine. Cryogenic engine is a kind of engine where we are using a very low temperature, and later on it is used to burn the fuel. And also the GSLV Mk3, which will be used to send the Gaganyaan mission in the space, will be fitted with an engine that has been called or that has been named as a Vikas engine, which is obviously indigenous developed engine system. So this is overall the technologies and the structure of the Gaganyaan mission. Now this Gaganyaan mission, though the ISRO is the main agency, but apart from that, this is a collaborative effort of lot of different organizations of India. The one such organization is the Shipping Corporation of India. Then the second collaborative partner is the Indian Navy itself. The third collaborative partner is the Defense Research and Development Organization, that is DRDO. Then we have National Institute of Oceanography, that is also playing a very pivotal role in the success of this mission. Then we have CSIR, that is Council for Scientific and Industrial Research, and in last we have the Indian Meteorological Department. So these are the 6 other agencies that are collaborative partner, and apart from that, they are playing a very important role in the success of this mission. The second important mission that ISRO is planning to launch this year is called as Aditya L1 mission. So let us have an overview about Aditya L1 mission. Aditya L1 mission, similarly as Gaganyaan is going to be the first manned mission of India in the space, similarly Aditya L1 is going to be the India's first mission to study the sun. Till now, many space organizations across the world have shied away from understanding the sun due to obviously very high temperature prevailing around its atmosphere. However, last year NASA was able to send its solar probe, that is called as Parker solar probe, and now India is planning to send its solar probe, that is called as Aditya L1. So obviously it hints that now mankind is more interested in understanding about how the sun works, and especially the outer atmosphere of the sun, because it affects us significantly. So the main objective of this Aditya L1 mission will be to place a 400 kilograms of satellite in the orbit that is called as halo orbit around the L1 point. L1 point stands for Lagrangian point of the Sun-Earth system. At the same time, the mission is scheduled to carry total 6 number of payloads in this particular halo orbit, and this orbit is situated at a distance of almost 1.5 million kilometers from the Earth. So obviously now we have discussed that the mission will actually place 400 kg satellite in the halo orbit around the L1 point. So what are these halo orbits and what are these L1 points? Let us try to understand about them as well. So if you look at the Sun and Earth system, what we can see from this diagram here, the total 5 Lagrangian points are identified. One L5 is around this region. Here we have Moon. So we have 3 body system, the Sun, the Earth and Moon. And these 3 bodies are revolving around each other. So what is Lagrangian point? Lagrangian point was a point that was identified by Lagrange, where he says that it is those points around this 3 body system where the net effect of gravitational force by 2 bodies balances each other out, and that is why these are the orbits or these are the areas of very low potential energy. For example, if you look at this particular diagram, this is the L1 point, and if a satellite is placed at this L1 point, the gravitational force exerted on the satellite by Earth is equal to the gravitational force exerted by the satellite on the satellite by the Sun. So due to this, what will happen? The satellite will not have to expend more amount of energy to overcome the gravitational effect, and that is why these are the most preferred points as far as the situations or the placing of satellite is concerned. So having been discussed about the orbit point and orbital space of this particular Aditya L1 mission, let us try to understand that what are the major payloads with which this mission will be fitted. So first of all, the most important part of this or most important component of Aditya L1 is something that is called as VELC. VELC stands for Visible Emission Line Coronagraph, and this has been developed by Indian Institute of Astrophysics. The main objective of Visible Emission Line Coronagraph or VELC is to engage in imaging and study of the magnetic field of the sun and other parameters that is related to the solar corona. Solar corona is the outermost layer of the sun which has a very high temperature of almost 1 million degrees Celsius, and this is a kind of still a mystery because the surface temperature of the sun is near 6000 degrees Celsius. So why we have such a high temperature of solar corona? Maybe through the missions like Parker Solar Probe and Aditya L1 we will finally be able to get the answers. The second important component of this particular mission is SUIT, also called as SUIT in the short, that stands for Solar Ultraviolet Imaging Telescope. This particular component has been developed by IUCAA, that is located in Pune, and the main objective of SUIT is to image the spatially resolved solar photosphere, that is again the outer part of the sun, and the chromosphere in the ultraviolet band of 200 to 400 nanometer. Similarly, the third important component is something that is called as Plasma Analyzer Package. In short, the acronym is PAPA. This component has been developed by the Space Physics Laboratory along with the VSSC, that is Vikram Sarabhai Space Center. And the main objective of PAPA is to analyze the composition of solar winds and its energy distribution. Solar winds are a recurrent phenomena that occurs from the coronal region of the sun. Scientifically, it is also called as coronal mass ejection or CME. These solar winds have a very important effect on the earth because it damages, or it has the possibility to damage or malfunction of satellites. It can even destroy or disrupt the power transmission on the earth, and can even damage the astronauts who are situated in the who are actually in the space stations by damaging their DNA. So understanding of the composition of solar winds and how the energy distributes around will be a very vital for understanding the overall effect of this phenomenon. The fourth important component is SOLEX, that stands for Solar Low Energy X-ray Spectrometer. This has been developed by ISAC, that is ISRO Satellite Center, and the main objective of this component is to monitor X-ray flares in the sun's corona to study the heating mechanism of this. As discussed just before, the coronal mass ejection includes different types of particles. They have very high energetic particles, they have plasma matter, they have different kind of ions, they have different kind of radiations. So one of the major radiation is the X-rays that will be observed by the SOLEX. The fifth important component is something that is called as high energy L1 orbiting X-ray spectrometer, that has been developed again by ISAC, Udaipur Solar Observatory and the Physics Research Laboratory in Ahmedabad. It will observe the dynamic events in the solar corona such as flares and the coronal mass ejection. And the last component is magnetometer, that has been developed by ISAC and Laboratory for Electro-Optic System. It will measure the magnitude and nature of the interplanetary magnetic field. So what is interplanetary magnetic field? As clear from the name itself, interplanetary magnetic field is the magnetic field of the sun that is emanating from the sun that is felt all across the solar system. So magnetometer will try to understand that as well. So overall, what we can understand about from these discussions, that the main objective of Aditya L1 is to not understand the deeper part of the sun, the deeper layers like core region of the sun, but to basically understand how the uppermost part, the outermost part like photosphere, coronosphere, corona, all these are working. So we can gain sufficient understanding about this. Now coming to the third major mission, that is Chandrayaan III, which is going to be a very important mission. And in this particular mission, the ISRO is trying to attempt a soft landing of the moon. The Chandrayaan II that was attempted in year 2019 did not achieve the desired result because there also the soft landing was planned, but by the time it started to descend on the lunar surface, the rover and the lander lost connection with this ISRO center, and that is why they smashed into the lunar surface. So that was a kind of hard landing. So as opposed to that, this time ISRO is expecting that the soft landing can be achieved. The overall cost of this mission is believed to be somewhere in the range of around 615 crore, that is almost 81 million US dollars. And it is believed that the Chandrayaan, if successful, if everything goes as per the plan, it can be launched as soon as August 2022. To remind you, all these space missions were planned in earlier years as well, but due to the COVID pandemic, all these things have to be delayed. So what is Chandrayaan 3 or how it is different from the Chandrayaan 2? So as compared to Chandrayaan 2, where we have used 5 800 Newton engine, Chandrayaan 3 will only have 4 throttle able engine. The engine in the Chandrayaan 2 was called as Vikram. At the same time, the one other instrument that has been added in Chandrayaan 3, which was missing in Chandrayaan 2, is something that is called as laser Doppler velocimeter. Laser Doppler velocimeter measures the velocity of fluid by using laser. and it is a successor of Chandrayaan II mission that unfortunately crashed on the dark side of moon year 2019 as discussed before. Not only these 3 flagship launches, we have some other launches as well. For example, ISRO is planning to launch 2 different PSLV missions in this particular year. At the same time, it will launch one geosynchronous satellite launch vehicle, one GSLV mission. Similarly, it will launch one GSAT-24, that is a communication satellite which will be for commercial players. And at the same time, it is also going to launch its one geosynchronous satellite launch vehicle Mark III, that GSLV Mk3. So total 5 different satellite launches are also being planned apart from these 3 flagships. So let us hope that ISRO and India as a whole will be able to achieve the success in all these coming missions. Thank you very much.